Hello, I welcome you all to this wonderful lesson. We are going to look at major types of chemical reactions that one needs to understand in chemistry. This is not to tell you that these are the only types of equations that we have. No, we've got several types of chemical equations, but I just want us to look at major types of reactions. These are reactions that will help you understand chemistry, that will also help you know how to predict certain products. So the first type of reaction that I want us to look at without wasting much of your time. So the first type of a reaction that we are going to consider is what we call a combination reaction. We get to call it a what? A combination what? A combination reaction. This is something that is so important. We get to call a combination reaction. What is a combination reaction? A combination reaction, this is a type of a reaction where you've got two or more products, or I would say two or more reactants. These are reactants. So I'll say two or more reactants to do what? To form one product. To form one product. This is what we mean by what? A combination reaction. So a combination reaction, this is where you've got two or more reactants that are reacting together to form one product. For example, you can have hydrogen molecule plus what? Oxine molecule to form what we get to call what? Water, which is H2O. So this is water that is being formed. So this type of a reaction, we get to call it a what? A combination reaction. So you need to understand that where two or more reactants get to react together to form one thing, we get to call those type of reactions what? We get to call them the name that is called a combination reaction. Like this one, we know that reactions that get to do with oxygen, they are sometimes get to be called what? Combustion reaction. So combustion reaction, this is a type of a reaction where a substance burns in what? Oxygen. So all those types of equations, they get to fall under combustion reaction. But when we say combustion, it's more like it is a general term. But combination, you'll be able to understand that when this and this react together, we form one product. This is the reason why I said these are what? Major types. We are just looking at major types. For example, you've got this magnesium gets to react with oxygen. What are we forming this side? What we are forming this side is called magnesium oxide. I guess we are able to understand. No one should ask me a question that why is oxygen? So elements like chlorine, hydrogen, nitrogen, I will say all group 7, I will say halogens. So all group 7 elements are called halogens. Halogens, I will say halogens, we get to have another one which is what? Which is oxygen. So just to list a few. These, when they are standing alone like this, when it is us alone, they get to have 2 like this, they get to have 2. So this unit, including all the halogens plus this one, they get to have 2 when they are standing alone. This is the reason why I'm writing like this. For this to be formed, I guess we understand that we've got magnesium that is like this. Magnesium is in group 2. Since it is in group 2, this is to tell you that it loses 2 electrons for it to be stable. That is why it has 2 plus. We go to oxygen. Oxygen, it is in group 6. It gains 2 electrons. So we say 2 minus. That is why these valences are going to cancel out to form this product that is here. you discover that elements combine together according to their valences. We check their valences. So they combine together according to their what? According to their valences. For example, you've got, so these equations are not balanced. I'm just giving you examples so that you can try to follow me closely. So in a case where you get to have something like, let's say you've got sodium plus chlorine halogen, you put a K2 there, meaning that the product that is going to be formed here, you know that sodium is like this plus, chlorine is like this negative. This is positive, negative, so meaning that their valences are going to change. Since these ones are 1, 1, so we are just going to have sodium chloride. So this is the sodium chloride that we get to talk of. So everything that is here, this is what we get to call combination reaction, where we've got two things or more that get to combine together to form one product. When two or more substances or reactants combine together to form one product, we get to call that type of a reaction combination reaction. This is all that you have to understand. Let us now move to the next one. We move to the next one. The next one, we get to call it decomposition. These are terms that some of you know. So we get to call it what? Decomposition reaction. What is a decomposition reaction? A decomposition reaction, this is a type of a reaction where one compound, where we get to talk of what? Where one compound breaks down. So here we are talking about one compound that does what? One compound that breaks down. So this is a breaks down. So that breaks down into what? Into two or more substances. In two or more substances. So this is something important that we have to understand. It breaks down into two or more substances. So one thing, it is going to break down. A good example that we can talk of is what we get to call, we can consider water. Whenever we've got water, when water passes through what we get to call electric current, when it passes through electric current, what we are going to have this side is something we are calling hydrogen will stand alone plus what? Oxygen, like this. So since water is passing through electric current, this type of a reaction is called electrolysis. This is what we call electrolysis. So this is also an electrolysis reaction where water is passing through electric current. So when it passes through electric current, we've got these products that will be formed. I'm just giving you these things. So at your own good time, you need to check through these and try to balance them. I'm just listing them for you so that you get to know these things, you get to understand them clearly. So I'm just giving you a guideline so that you are able to understand. So this type of a reaction is called what? Decomposition. One thing is breaking down into two or more substances. These are two products that are being formed. I told you to say, what is a compound? A compound is a chemical combination of two or more elements or substances. So it is a chemical combination. This is a chemical combination of two or more substances. This is what you have to understand. We've got another type where we've got this one, we've got calcium carbonate. So when calcium carbonate decomposes, this one, a catalyst that should be there is heat. For it to decompose, we need to have heat to get the products what? Calcium oxide plus what? Carbon dioxide. These are the products that are being formed. What do we call this type of a reaction? This type of a reaction is called what? thermal decomposition. It is called what? Thermal decomposition, because we are breaking down this compound using what? Using heat. So this is the reason why we are calling it thermal decomposition. I guess we are writing down the notes and we are moving together. These are the major types of reactions that a student needs to understand. So even as we get to move forward, you need to make sure that you are able to understand all these things. You are able to explain to a person that this type of a reaction is called a combination reaction, because we've got two or more reactants that are reacting together to form one product. And when you go to decomposition, you're able to explain to a person that this is a type of a reaction where one compound breaks down to two or more substances. I guess we are able to get this. We are able to understand all these things that I'm explaining to you. So I guess you know this. I guess you are able to understand this. Let us now look at another type of a reaction. So the other one, so before we look at another one, we've got silver chloride. So let me say silver chloride, which is like this. So when silver chloride breaks down like this, what are we going to form? We are going to form what? Silver plus chlorine. This is what we are going to form. So this silver chloride, what it gives us, you discover that this silver chloride is exposed to what? To sunlight. So silver chloride is exposed to sunlight. The use is that it is used in black and white what? Photographies. So it gets to be used in black and white photographies. This silver what? Silver chloride. So this is a silver chloride. When it breaks down, this is what is formed. So this is what you have to know. I guess we are getting the sense out of these things that I'm teaching to you. Let us now look at another type of a reaction. We look at another type of a reaction. So when I guess all of you've passed through biology, you discover that whenever we are looking at digestion, so if I ask you, digestion of food, is it by displacement or decomposition or combination? So when digestion is happening, you discover that digestion is a decomposition reaction. That is a what? A decomposition reaction. Because we've got certain food substances that are broken down into smaller ones. For example, proteins are broken down to amino acids. So that is what one thing which is a protein breaks down to amino acids. So what is happening is a decomposition reaction. That is what is happening. Let us now move on now to another type of a reaction. I guess you are able to follow me clearly. I guess you are able to understand everything that I'm teaching here. The most important thing is knowing these things. You get my explanation, then things will be okay with you, even in your exams. There's what we call a displacement. So there's what we call a what? A displacement reaction. This is a what? A displacement reaction. So a displacement reaction, this is where we have, where a what? Where a more reactive, have you seen? A more reactive element. So a more reactive element displaces, so displaces less active what? Active, less active element. This is a displacement reaction, where you've got one thing that is more reactive gets to displace the less reactive element. So in this now, there are what we call reactivity series. We now need to understand the what? Reactivity, I'll say reactivity series of metals here. The reactivity series of what? Of metals. How is it? So the reactivity series of metals is like this, where it is like this. We've got I will say we've got potassium here, we've got sodium, we've got calcium, we get to have magnesium, we've got aluminium, we've got zinc, we've got iron, we've got lead, we get to have copper, we get to also have what we get to call mercury, and we've got gold. So this is the reactivity series. This is more reactive. Have you seen more what? Most reactive. So most reactive, I'll say most reactive. So this is most reactive. Going to what? Going to less reactive. So the arrow is going there to less what? Less reactive. These ones are less reactive. So this is the reactivity series. This is to tell you that potassium is more reactive than sodium. Sodium is more reactive than calcium. Calcium is more reactive than magnesium. Magnesium is more reactive than aluminium. So there is this reactivity series. You need to do everything possible to know it, because you are going to face challenges, because there are certain reactions that will exist that are not even there. They're just there to test your mind. For example, under the displacement reaction, you can have a reaction to say when copper reacts with what? Copper reacts with the iron sulfate. So iron sulfate, what is the product there? What is the product? So in your book, somebody to tell me the products there, somebody to tell me what is going to be formed. What is the product here? What is the product? Here there is no reaction. No what? No reaction. This is what you need to understand. There is no reaction here. There is no reaction. How did I know that there is no reaction here? Because this one is what we get to call a single displacement. So this is a displacement reaction, also known as single displacement reaction, where we've got this one that gets to displace a metal that gets to be there, or a non-metal. Since this is a displacement of metals, so this copper is less reactive than iron. Have you seen? Which means that copper cannot displace iron. Have you seen where copper is? Copper is here. Have you seen where iron is? Iron is here. So this is to tell you that iron is more reactive than the copper that is there. Have you seen? So copper cannot displace iron. So this type of a reaction does not exist, because copper cannot do what? They will tell you that why is it that when copper reacts with iron sulfate, there is no reaction? Why is it like that? You get to have such questions in an exam. You have to understand that the reason why it is like that, because copper cannot replace what? Iron. Iron is more reactive than copper. So here there is no any reaction. There is no reaction here. This is what you have to know. There is no any reaction here. No reaction. But in a case where, so this is these are examples that I'm giving you. So you discover that they may ask you that what happens when iron nail is pressed in copper sulfate solution. So in a case where we've got iron gets to be pressed in copper sulfate solution like this, what are we going to form this side? So this is copper 2 sulfate. When it is like this, you need to understand that it is copper 2 sulfate. So what is going to happen is that this iron can now replace the copper here. So what we are going to form, we are going to form iron what? Iron sulfate plus copper. So this is what we are going to come up with. This is what we need to understand. This is why this one thing you are going to observe is that there's gonna be some color changes. This iron sulfate is going to be what? Is green in color. This is green in color, but the copper sulfate that is here, the copper sulfate is blue. So you discover that there's gonna be some color changes. So color changes, and this copper that is here is going to be reddish brown. This one is going to be what? Reddish brown. These are certain things that you need to understand. I'm not only teaching you these things, I think you are even able to see that I'm also touching anything that crosses my mind. I'm telling you because I want you to understand these things. They'll ask you these questions in an exam. People get to be confused. Those questions we don't know where they get to fall under. We don't know the topic they fall under. But these are things that we are supposed to know. These are certain things you have to understand. So there is a special name that you have to understand for you to know the reactivity series. This is the reactivity series of metals. A special name for that for this reactivity series, there is a name I used to sing at school. I used to say posokama. I would say posokama ziu ikom sip. This is what I used to say. This is the reactivity series. This is the name. Have you seen? You know that this is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen. We've got copper, mercury. So you are just following it like that. Have you seen? You've got silver. So this is what you have to understand. This is as a small, then we've got so plus this, then lastly you know that there is God. You need to understand the God at the end. So posokamaziu I, sip, go. So I'll do this so that you know that there is God. This name, you need to understand it. It is going to help you. You say posokamaziu I, sip, go. You know that is the activity series. Then you start breaking it down. Potassium, sodium, calcium, magnesium, aluminium. We've got zinc, iron. We've got lead. We've got hydrogen here. Have you seen? So this is what you have to understand. So after lead here, have you seen? After lead there is a hydrogen. So I made a mistake. After lead, between lead and copper here, there is a hydrogen. I forgot about it. So there is hydrogen. You can include it. Have you seen? So this name, you have to understand it. It is very simple for you to know this name that is here. You just need to understand it. So we've got, this is platinum. So have you seen? It is not even that reactive. So this is what you need. This is the reactivity from the most reactive to the least reactive. This is the reactivity series that you need to. This is the reactivity series of metals. But we also have what, I guess this is just like a crook name that that is popular. I guess most of you have heard of this. This is not new. This is something that is there. People get to say it. It's everywhere. There is also what we call the reactivity. Reactivity of what? Of non-metals. So the activity series of non-metals. This reactivities, the activity series of non-metals is very simple. There is something that we get to call. So in a case where you've got, let me say, fluorine. Let's say you've got fluorine there. Let me say you've got chlorine. We get to have bromine. We get to have iodine. So this is how it is. Have you seen? This is the reactivity series. So meaning this is the most reactive. So most reactive. Going down, so iodine is less reactive. So these are some things that you are supposed to know, certain things that you have to understand. I guess you people are able to follow this clearly and attentively. So this is just like a simple thing that you have to know. So you need to know that, okay, chlorine is more reactive than iodine. Chlorine is more reactive than what? Bromine. So this is what you have to know. This one is the least reactive. This is the I would say least reactive. So say less, let me say less reactive, just like this. So these things, you just have to know them. You just have to understand them. Let us now go to the fourth one. I'm even explaining, this is the reason why we are taking time on these things. If I was just to mention them, okay, this, would have done. By now we were supposed to be done. We now go to the fourth one. The fourth one is called double displacement. Now, what we are from looking at is single displacement, but this one we get to call it what? Double displacement reaction. So we are calling it double displacement what? Reaction. This is the name. So it is called double displacement. Some people call it double decomposition reaction. So you get to understand it that way. In that, you've got two compounds. So two compounds here, you've got two compounds react. So two compounds react with each other. React with each other. They react with each other and exchange and do what? And exchange. They get to exchange their what? Exchange their ions. So they get to exchange their ions to form what? To form two new products or new compounds. To form new what? New compounds. This is what gets to happen. So whenever we are talking about double displacement, where you've got, for example, you can have A, B reacting with the C, D. What are the products? There is a crook way. You say this is 1, this is 2, this is 1, this is 2. So the one that is here is going to react with the 2 that is here. So we are going to have A, D. 1, 2. We are supposed to have 1, 2, 1, 2. So the one that is here reacts with the 2 that is there. So A, D plus C. Then 1 here, C reacts with the B that is there. 1, 2. So we are going to have B, C. So these are the products that get to be formed. So here, under double displacement reaction, we don't follow the reactivity series. The reactivity series is only applicable to single displacement reactions. Under double decomposition, we don't follow the reactivity series. So we are not supposed to follow the what? The reactivity series. I guess this is entering you. The reason why I'm shouting like this, because I want you to understand. I want you to know this. Under double decomposition, we don't follow the reactivity series. This is the reason why, even if you don't know the reactivity series in chemistry, you still end up getting a distinction. Because most of the reactions don't literally involve the reactivity, but it is very important for you to know the reactivity series. If you are a student of chemistry, one of the things that you should know is the reactivity series. When you tell the person that, okay, do you know that this is reactive than this? The reactivity series is this, there is also the periodic table. You are able to know those things without even checking. A person will know, this person is bad in chemistry. But not whereby the activity series, you want to check your the phone or maybe your books. A periodic table, what is the mass number for magnesium? You want to check the periodic table. No, it shouldn't be like that. So this is what gets to happen. For example, you've got, let's say you've got silver nitrate reacting with sodium chloride. What are we going to form this side? So kakurukwe, this is 1, this is 2. This is 1, this is 2. So the 1 here will react with the 2 that is here. So we are going to have silver chloride plus C. We've got the 1 that is here reacting with the 2 here. That is what? Sodium nitrate. At this point, I assume that we all know how to come up with correct chemical formulas. So have you seen what has happened is that they have interchanged. The 1 that is here has gone this side and this one has gone that side. They have just exchanged their ions. This is what has happened. So don't say, I don't know how to predict the products in a decomposition or in a double displacement. This is what I'm doing here. This is what you need to do. So in a case where you've got something like this, So in a case where we've got, let's say, sodium hydroxide that is reacting with the hydrochloric acid, what are we going to form here? You cut them. This is 1, this is 2. This is 1, this is 2. This is just like a short way, like a crook way of knowing the products without any struggle. So we say, okay. So here we've got 1 and 2. So this is sodium chloride. So we are going to form sodium chloride plus, we've got this H reacting with an hydroxide, we form water. How did I know this is a salt, this is water? This type of a reaction is called neutralization reaction. So this is a neutralization reaction where we've got the base that is neutralizing the acid that is here. So this is called a neutralization reaction. If you don't know how a neutralization reaction looks like, this is the one. This is a neutralization reaction. This is something that is so easy to know, something that is so easy to understand. I guess you people are able to know these things, you are able to understand them. This is something that is so simple. So you now discover, apart from this, there is also a type of a reaction where we've got maybe lead nitrate. Lead nitrate gets to react with the potassium iodide. What are we going to form this side? A secret, this lead will react with what? This lead, we say 1, this is 2. This is 1, this is 2. So what are we having this side? What are we having this other side? 1 goes with a 2 that is there. So which means we are going to have 1, we've got lead iodide. So we are going to have lead iodide like this. Plus now what we are calling potassium, potassium nitrate. So potassium nitrate is just like this. So this is what we are going to have. This is to tell you that this one that is here, this is a precipitate. This is a what? This is a precipitate. You need to understand that this is a precipitate. So since this is a precipitate that gets to be formed, then this type of a reaction is called a precipitation reaction. I guess you know precipitation. So this is a precipitate, so meaning this type of a reaction is called a precipitation reaction. So this is some of reactions that you have to understand. Let us now look at the last one, the last type of a reaction, then we are done for today. So I guess you are able to write down everything that I'm explaining. I'm putting an emphasis. I'm not balancing this because I just want us to look at, we get the concept. I'm not balancing them so that you may understand. They are what we call redox reactions. They are what we call what? Redox reaction. Redox reactions means what? Meaning what? Meaning oxidation, means that oxidation and reduction reactions. Reduction reactions. So when we say this is a redox reaction, it means that where oxidation and reduction is taking place. So they are called what? Redox reaction. You quite right. We are able to understand that whenever we are talking about oxidation, you are going to agree with me that oxidation, how do we define oxidation, or what is oxidation? Oxidation is the addition. We say this is the what? This is the addition of what? Addition of oxygen. What is a reduction? What is reduction? What is reduction? Whenever we are looking at a reduction, you have to understand that this is now the addition, just the opposite. Here it is the addition of hydrogen. Have you seen hydrogen? These are two important things. So where these two gets to occur at the same time, we get to say that one is a what? Is a redox reaction. So you discover that redox reactions can be can fall under single displacement, but here you need to know which one is being reduced, which one is being oxidized. So whenever we are talking about the addition, this is the addition of oxygen, meaning it is the removal. We get to remove what? We get to remove hydrogen. Since this one is what we are calling what? Addition of, we are calling it what? Addition of hydrogen, meaning it is the removal of oxygen. We are removing oxygen. Have you seen? Removing what? Removing oxygen. So these are two things that you need to understand. Under oxidation, in as much as we are adding oxygen, we are removing hydrogen. Reduction, we are adding hydrogen but removing oxygen. So this is what you need to understand. I'm going to share a table that you are going to see in the group. Just after this particular lesson, I'll share something that you are going to understand. So for example, you've got copper oxide gets to react with hydrogen. What are we forming this side? What are we forming this side? Have you seen? We are going to form copper plus what? Water. So this is a single displacement reaction, but it is undergoing a redox reaction also. Where you know that, have you seen here, with the copper, we've removed what? What have we removed? We've removed oxygen. So on the copper, we've removed what? Oxygen. So meaning that this one, this copper is what? Copper is reduced. Copper is what? Copper is reduced. So copper is reduced. And on the hydrogen that is here, it has become what? Water. Meaning that hydrogen is what? Hydrogen is oxidized. This is what you need to understand. Meaning oxygen has been oxidized, addition of oxygen. But copper has been reduced. Have you seen? Copper has been what? Reduced. So this is what we call reduction. So it has been reduced. Removal of what? Oxygen. We've removed oxygen here. So this one that is being reduced, we are calling it what? We are calling it an oxidation agent. So since this one is being reduced, so there is something here. You need to understand the confusion here now. Since copper is reduced, is what? Is reduced. Since copper is reduced, then it is an what? An oxidizing agent. It is an oxidizing agent. It is an oxidizing what? Oxidizing agent. Since hydrogen has been oxidized, meaning this hydrogen is what? I guess you are able to see the confusion that is here. This one that is being reduced, see, because it has been reduced, we are calling it what? An oxidizing agent. Since hydrogen is what? Hydrogen is oxidized. Because it is oxidized, we are now calling it what? Then it is called what? It is called what? It is we are calling it a reducing reagent. We are calling it a what? A reducing reagent. Reducing agent. We are calling it a reducing what? A reducing agent. So these are certain things that you have to understand. I guess you've seen this, and I guess you've understood this part that is here. This is some things that are simple. So because it is reduced, we are calling it an oxidizing agent. Because it has been oxidized, we are calling it what? We are calling it a reducing agent. So this is where we end from. I guess you've understood this part, and hoping for a positive response in the exercise that we are going to do.